So let's go large as well. Here it is. All right, sets of Venn diagrams. You've done a little bit of this in year 8. It will go further in year 9. You may recall that this squiggly Greek letter X is a squiggly Greek letter X. It represents the universal set from which you extract any sets you want to be comparing. High time submitting. So in this question, I did say I'll go over question 6 as a unique video. Set A is defined as, please note Faz, in squiggly brackets, not square brackets. The correct notation for this topic is curly brackets, which is hard to draw, but that's how you do it. So set A is defined as the multiples of 2. Set B is defined as the factors of 24, but please note the entire universe of numbers from which we select A and B only goes from 1 to 10 inclusive. So here's the universe of numbers that I've drawn out. Here is set A, the multiples of 2, in other words the even numbers. And these are the factors of 24, that is to say numbers which divide into 24 exactly and leave no remainder at all. So again, I could have gone, after that is 12 and 24, but 12 and 24 are outside this particular defined universe. Now, the numbers which belong to both sets, A and B, go into this region called the intersection. So 2, 4, 6 and 8 are both multiples of 2 and factors of 24. This 10, which is part of the wider set A, but this 10 alone is a multiple of 2, but clearly is not a factor of 24, because 10 does not divide into 24 exactly and leaving no remainder. In fact, it will give us a remainder of 4, which is not what we want. Set B then, so we've got 2, 4, 6 and 8 as being factors of 24. We also have 1 and 3 as factors of 24, but they are not even numbers, so they will not go in the intersection. So 10 alone, 2, 4, 6, 8 shared, multiples of 2 and factors of 24, and 1 and 3 specifically factors of 24. Are there any leftovers? Yeah, 5 is part of the universe. It's neither a multiple of 2 nor a factor of 24. Same with 7. Same with 9. Now, the textbooks asks you to do this via. So via gave me this, and but what you didn't do via is just to write down the question. So you never wrote down A union B, which is why I emailed you back. So A union B are all the numbers that are within A and within B and within the intersection. I don't know if you can see that, but I've actually copied this many times over because you need to know how to shade in certain parts of Venn diagram. And it's all the same. I went over it again because it looked terrible. It wasn't that clear. But essentially it's the same copy paste. So look at this one. I don't know what question it is. I know it's 6 something, but it doesn't matter. You've got these screenshots, this sort of size. Please would you print them off, especially if you've got a colour printer. If you don't have a colour printer, it's black and white, it doesn't matter, but you need these notes for year 11, but right now working towards a question, a subsequent task. So this stands for A union B. We're going to unite set A and set B, and in so doing we're going to unite the overlap region as well. It's obvious. And these are all the numbers that belong to set A and set B. And these are the 3 on the outside that belong to neither. That's easy to understand. Now I'm going to go over to here. This is called A intersection B. We're looking at uniquely the place where A and B meet and where we have elements belonging to both sets. If you like, these are the children. I don't know if I used that term last year, but I see these as the children of set A and B. Yeah, this is the children of set A and B, and this is the entire family of A and B. All right, so A, N, B is the intersection of A and B, and I've written them out here. So for question 6, all it wants is that and that. but you need this and this, and I'm showing you what it means on the diagram as well. Again, you can stop me at any time because this is a teaching lesson, it's not a lecture. This A dash, two ways of saying it. You can say the complement of A, or the Americans call it A prime. Essentially it means not A. So who are the elements that do not belong to A? Well, keep your eye on the whole of set A, which means 1 and 3 are not part of A. 5, 7 and 9 are not part of A. So if at GCSE you're required to shade in A prime or A dash, then you shade in everything outside of A set and you get that mark. It does get a bit more complicated. So the elements not in A is called the complement of A. If you like, those in A are complemented with those not in A to make a complete universe. As you can see, that's quite clear from the picture. A plus everyone else is the whole universe. Hence, the yellow stuff completes set A in terms of the universe being complete. And of course, I couldn't resist but to do this one. B dash, B prime, is the complement of B. In other words, everybody that's not in B is shaded. So you shade all outside set B, right to the edges as best as you can, but don't be too sloppy with it. You can do much better job than this Mimeo thing. So this means not B. That's not A, the yellow stuff. Here are the not B's. In other words, 10, 5, 7, 9, and there it is. And please, I say again, print this off if you can, or email it to your parents to print off at work if possible, but you want this, otherwise you've got a lot of copying. Here's more of them, and I don't know if they come from the questions in the textbook or I was just making them up. Some of these are going to get very, very tricky, and I'll probably get stuck thinking about them. Now, this means A in union with everything that is not B. Okay? Now, you won't accept this. It wants to be in A, so all of this must be included. And I mustn't be part of B. In other words, I've got to shade everything outside of B. Got it? So I'm shading everything outside of B, and I'm shading everything in A. So how would you read this? It's the union of everything in A with everything not in B. But sir, in the intersection, 2, 4, 6 belongs to B as well. I know that, and that's the difficulty in the thinking. Even at year 11, it's difficult to think around that. I'm taking all of A, there it is, including 2, 4, 6, and I'm marrying it to everything that's not B. In other words, everything outside B. Okay, so but that's correct actually. So you're going to name everything apart from 1 and 3. These elements do not belong in this set. Okay, in this arrangement. I can't call it a set because it's set A united with everything not in set B. Difficult. I mean, this is like the reverse version of that. This is B united with everything not in A. Well, everything not in A is all of this in white. Sorry, everything in A is everything in white, including the 2, 4, 6, which is part of B as well. So I've got to have everything in B. In other words, 1, 2, 3, 4, 6, 8. I'm going to have all that. I'm going to unite that set with everything that does not belong in A. And everything that does not belong in A is out here somewhere. All right? So that overlap again is included in the same way that this overlap is included in this scenario. Again, difficult to get your head around that, but you've got to think about it. So the elements that belong to B union A prime or B union with complement of A are these numbers right here, the ones in the yellow, not the white thing there. All right. Now the next two, again, very tricky. This represents A, elements in A intersection with everything that is not B. everything that is not B. So let's study this very carefully, see if I got this right. I must be in A and I must not be in B. So whereas you want to shading the whole of A, because it says you must be in A, you are now not in union with B, you're in intersection with everything that's not B. I must be in A and I must be not in B. So sir, why don't we shade it out here, because that's not B. I know, but that part of A does not intersect with the outside. It unites with the outside, a bit like this. So these are the two things that are confusing, very difficult. So the way to say it is, I must be in A and I must not be in B. So B stays white and open, yeah, not shaded. Since I must be in A, I'm not allowed to be outside of A. All right, so it's just that little part of A that's shaded. I know I crept into the overlap here. That's just me using a bulky shading pen right there when this was turned up quite high, as it takes a long time to shade. So this represents A intersection with everything that's not B. Okay, and there's only one actual member of that scenario, and that's just the 10, because that's in A only and it's definitely not in B. And so I'll flip this one round the other way as well. I want to take B and I want to intersect everything that's not in A. So not in A is everything outside here, but I'm not uniting with that. I have to collide with it, intersect with it. So it's the complete reversal of this one here. So read it this way. I am in B and I'm not in A. So I can't be in here because that puts me in A. I certainly can't be here because that puts me in A only. Okay, so the elements that correspond to B intersection A dash are these two here, the 1 and the 3, again in a very badly drawn curly bracket. And that's what I gave you. Now that is off spec. We're not going to do that. So I'm not going to, I did it last year. I won't do it anymore. It has no representation at GCSE. So that's where we are. I can't go through all that again, but I'm recording this so you can listen again. I've noticed that many of you have your lesson, do your work, kind of, and then just walk off. Listen, I'm putting this up on YouTube. This is tricky. Getting all this around your head is very, very difficult. These are easy. Union, intersection, not A, not B. That's quite easy. These are the dodgier ones. And GCSE won't take you beyond what you've just seen there. All right. So you've got 8 little scenarios, and there is no other combination. That's it. Okay. So I need to stop right now.